this video, we're going to continue with what we were looking at in class today. So we had 4 charged particles that were a distance r away from the center. And we were looking for what is the potential at point P in the middle. So if we were to add more charges, put one there, almost kind of making a circular shape. And we gave each of these charges a value of positive q. And every one of them is still that distance r away. We would do the same thing that we did for the 4 that were in a square pattern. Now we just have 8 that are in the circular pattern. So the voltage is still going to be the sum of all of the k, q over r's, where if each of them have a charge of q, that's a constant, so we have k, constant for all of them, q, and r, but we just have 8 charges. So 1 q for charge 1, 1 q for charge 2. Messed that up, didn't I? 1 charge for charge 2, plus 1 charge for charge 3. I'm sure you get the deal. 4, 5, 6, 7, 8. And all the charges, you can see that we get a total electric potential of 8 kq over r. Add 2 more charges in there, you get 10. 5 more charges, 13. All right. What if we change the shape of our arrangement here? So instead of putting 8 charges in a circle, we put them in an arc pattern. Looking for field at point P. This arc has a radius of r. Each charge has a value of positive q. So, same idea. So, this charge right here is a distance r away, has the value of positive q, k is constant. This charge right here, same thing. Value of q, distance r away. Doesn't matter what arrangement they give you. Sometimes they'll make it look a little different. Say, hey, there's an angle here of 120 degrees. Since it's not a vector property, the potential is not a vector property, the direction that this potential is coming from doesn't matter. So remember I talked about if, running out of colors here, this charge has a potential going around it, and that provides like height on a surface, then this one does the same thing, that one does the same thing. So they're basically just stacking mountains on top of them. So if you have 8 charges, it's still going to be the same value, whether it's in an arc or whether it's in a circle, or whatever other shape they want to come up with. So let's take this one step further. And here I'll just have one big charge, and I'm going to pretend that this is a malleable conductor. So I'll be able to change the shape of this conductor. Maybe it's mercury, and we can just pour it into a different container. All right, so same thing. Want to figure out what the voltage is at point P, some distance r away. This makes sense. This is the simple just hey, it's KQ over R. I only have one charge. That one charge is R distance away. That's going to be the potential. So if I take that charge and I stretch it out, so that it is a thin curved wire with radius R. Still has a charge of positive Q. I didn't add more charge like I did with the particles before. So it's just the same charged object, somehow able to change the shape without changing the charge. Because every bit of that charge, every little dq there, is a distance r away, this would actually be a dq over r, right? Because we would add up all those little dq's that are all the same r away, just not in my diagram, that's definitely not drawn correctly. So that k is a constant, every dq is at r away, so we just sum up every little bit of charge. And we'll get the same exact answer than it was whenever that charged object was a spherical shape. You can stretch that out even further. And turn that charged arc into a really thin charged ring. So this is no longer a sphere. And because we're just changing that object, we're not changing the charge. And if we looked at the center here, that was r away. So we basically wrapped it around in a circle. Same idea. K is constant. Every little dq is the distance r away. So r is a constant. Add up every little piece of charge, and that will give us k, q over r. Doesn't matter. Doesn't matter the shape, just matters the amount of charge. We, of course, are going to take this one step farther and look at a difficult situation. Not the line I wanted. So if we have a line of charge, I'm looking for the potential at point P, and each of the little dq's now are at that different distance r away, right? I'll do that in another video.